I'm going to show you how to do some of the problems in Chapter 8, Section 4 of the textbook. This is where we estimate the population proportion given a sample. So we have this problem. We have a computer manufacturer who's making computer chips. They make an undisclosed number, but there's a bunch of them. We take a sample of just 200 of those chips, and out of those 200 chips, we find that 4% are defective. They want to know with the 99% confidence interval, what's the percentage of all computer chips from the factory that are not defective. So I'm going to look at three different ways of doing this. One is the long way, one's using Excel, and the other one's using the calculator. So let's do the long way first. So here, in order to do the long way, you have to do the equation where you find your error estimate and multiply that by your z-score and multiply by the square root of the sample proportion and 1 minus the sample proportion over the number of samples. So we know all this information. We know our confidence interval is 99%. So n, our sample size is 200. Now we're looking for what are not defective. So 1 minus p hat was the 4% that were found to be defective. P hat is not defective. There's the remaining 96% that are good. So p hat is the percentage in the sample that were good computers, so 96%. With a 99% confidence interval, when we look at the graph and look at our charts, we're going to go out with a two tails test, 1% on either side. That means we look up 0.995 area in the chart, and we come up with a z-score of 2.576. Our estimate is going to be for P, which is the population proportion, is going to be plus or minus the error estimate to the sample proportion. When we fill in what we know, we come up with our error estimate of 0.0357. We subtract that from the sample proportion and add it to the sample proportion, get the upper and lower boundary for the confidence interval for the population, and we find it's around 92.43% to 99.57% of the population computers at this factory are not defective, that are good computers. And 99% of the time when we get a sample that had this 96% good computers would result in this confidence interval for us. That's doing it the long way. Now if we use Excel, one of the things I want to show here real quick is that in order to do this test, we have to make sure that the sample size is big enough. And that's this criteria here where n times p hat has to be greater than or equal to 5, and so does n, and the inverse of that. So that's the first thing I do here in Excel. Over here is I just test. I come up with 192 and 8, so it's greater than 5, so that means I can proceed and I can use these equations. Our sample size n is 200. Our confidence interval is 99. That means the alpha, the size of the tails, what remains is 0.01. P hat, that was the sample proportion, was given. And what we looked up for z was the 0.995 area under the curve. And our z-score, that should be z, is a 2.5758. and we come up with our margin of error. That was the error, and we get the same result, just one more decimal place here with Excel. I could expand it out to further decimal places. And if I do Control tilde, I can show you the formulas that are used. I'm using the norm.s.inv in order to figure out the z-score. Here's the equation for the margin of error, taking that z-score, doing the square root formula, and adding and subtracting that error to the sample proportion to get the upper and lower points. If I wanted to do this on a calculator, so here's our TI-84 calculator. We hit Stat, and this is going to be a test. So we pan over to Tests, and we have to scroll down. On this calculator, it's A for the proportion test. See here? The population proportion Z interval. So I'm going to choose that one. The X, we're not given X. X is the number of good computers that were in that sample, but I can calculate that. I can take the number that of the sample size and the percentage of good, and I can calculate that there was 192. So it's 192 that were good computers, and there were 200 in our sample size. Our confidence interval is 99. I tell it to calculate, and there I get my confidence interval, and it matches up with our Excel and also the doing it by hand. So we get the same numbers for our confidence interval for the population proportion.